These diagrams are very important. Like I told you, the deflection that is caused. So when the alpha particle is deflected towards the negative plate because it is positive, and beta particle is deflected towards the positive plate because it is negative. What is very important for you to note that the beta particle deflects early and an alpha particle deflects late. This thing. The reason is that it is heavy. Alpha particle is a helium nuclei. Okay, remember, one proton or one neutron is around 2000 times an electron. And here there are 4 of them. So almost 8000 times the mass of an electron. So the electron will definitely move earlier, deflects earlier. It's like if you are standing and if you throw a paper ball, it will immediately drop. But if you throw like a cricket ball, the ball will go further and then it will drop. So it's heavy. Okay. Fine. Any questions? This is magnetic field. We will study about the nature of the magnetic field in another chapter. But for now, you should remember the following. If the magnetic field is perpendicular to the paper pointing inside the paper, the magnetic field is denoted by these crosses. Okay, so the magnetic field is perpendicular to your computer screen pointing inside the screen. That time, alpha particle, which is positive, is deflecting to the left. And beta particle, which is negative, is deflecting to its right, to your right. You need to remember this. Now, what if the magnetic field is perpendicular but coming out? That is denoted by dot and a circle around it. Okay, so this is how we denote a magnetic field.
The dot and circle part.
Okay, dot and circle. When the magnetic field is perpendicular to your computer screen, coming out towards your face, that magnetic field is denoted by this way. But when the magnetic field is perpendicular to the computer screen going inside, it is denoted that way. Now, this is very obvious to know now that if the alpha particle is deflecting to the left, then alpha particle will deflect to the right over here, and beta particle will deflect to the left over here. Do you have any more questions?
No, sir.
Okay, so what are we left to do? We have to see, that is what we will do in our next class, the harmful effects of radioactive isotopes, what safety precaution that we need to take, what is background radiation. Okay, so this whole thing we will do, and there are some easy equations based on alpha, beta, and gamma that we will do, and we have to start with the chapter sound. So this is what we will do when we meet on next Friday. Thank you. Okay, so the next part of this chapter is harmful effect of radioactive substances. Now, in harmful effects, you have to understand that the biological effects can be short-term recoverable, okay, like diarrhea, sore throat, loss of hair, nausea. So the people who are working in nuclear power plant or where nuclear substances are handled, they can face such effects, okay. There are long-term irrecoverable effects like leukemia, cancer. So that is that's a problem with radioactive radiations. They do cause these things. The third thing is a genetic effect. Okay, so the genes get modified or mutated because of the exposure to the radiations. Now, these two are affecting a person, but genetic effect can last for generations. So the kids who are born to people whose genes are mutated will have certain defects in their body. Okay, so that is the reason why a new exposure to nuclear substances can be harmful. Okay, moving ahead now. So what are the safety precautions that one has to take? Again, safety precautions is categorized into two different things. So we will see the first one now. So this is the safety precaution for handling radioactive substances. So people who are scientists, research scientists, or even the people who are working in the nuclear power plant have to abide by certain safety rules. Like they have to wear lead-lined aprons, lead gloves. Okay, well, when they are handling the radioactive substance, they have to use long lead tongs and not to hold it in their hand. Okay, then the safety limit for radiation should be known. Okay, so when these scientists or workers are working on their uniform, there is a special badge. So the badge color change indicate the amount of exposure, and then they are taken off. So such things are there. Radioactive substances are kept in thick lead containers. Okay, and so lead containers stop the radiation and prevent the radiation from escaping and harming others. So this is a safe handle of radioactive material. But the other kind of safety precaution is to establish nuclear power plant. Okay, the walls of the plant must be shielded with lead, steel. Okay, so the concrete walls are like 2 to 3 meters thick. Plus, there is lead and steel reinforced, so that from the nuclear station, which are generally on the outskirts of the city, there is no escape of radiation from them. So if you are near this facility, outside the facility, there is no chance that you will be exposed to any radiation. Okay. The nuclear reactor building must be airtight, must be concrete, and it should also be able to withstand earthquake. Okay. So in case of an earthquake, it should not get damaged and the radiation should not leak into the atmosphere. Then this is also important. That is, it should have a cooling system for the reactor core, so that in case of a tragedy, it can be cooled properly and shut down, and should not create any explosion because of overheating. So again, coming back to that part, so this is safety precautions which are there. Okay, then the next important part is safe disposal of the nuclear waste. Now, nuclear substances, students continue to remain radioactive for hundreds and thousands of years. So you can't put them in a landfill or something. You can't just ignore them. So the radiation level that they give out may be reduced and it may not be useful in a nuclear reactor, but still they have to be safely disposed of. So that again is an important question. We generally do get asked in the exam, that safe disposal of nuclear waste. So nuclear waste should be kept in thick lead casket. That is point number one. And they must be buried in empty, useless mines or deep in ocean. So these are the 2 points which are required for this answer. Safe disposal of nuclear waste. So the nuclear waste can be coming from laboratories, hospitals, scientific establishment, or nuclear power plant. All of that has to be brought together, kept into lead boxes, and then it has to be kept into empty, useless mines. Mines where people dug up uh, deep into the ground. So keep it down below and keep it in deep ocean. Okay. Please remember, you have to write both points, not only one point. Okay. Moving to the next part over here, that is background radiation. What are background radiations? Okay. So now background radiations are radioactive radiations from alpha, beta, gamma that we are exposed to without actual visible radioactive source. That means right now we are in a house and still we can be exposed to these radiations. If you search on internet for K40, potassium 40, now this is a component of sand mostly, and depending upon which part of India you are, the sand content of K40 can be more or less. Now this sand is used to build houses, okay, the cement mixture and all that. So therefore, some portion of K40 is there in our walls, okay, and it is radiating this radiation. But that is so less, so small that it does not cause any serious biological damage. Okay, not only an example of K40, but there are cosmic radiations coming from outer space, and we are fortunate to have an atmosphere that absorbs most of it. Okay, and still there will be some radiation that do reach the Earth. So that is also called as background radiation. So background radiations are the alpha, beta, gamma radioactive radiation that we are exposed to without the source being actively present over there. So these are categorized as internal sources, okay, and external sources. So carbon-14 that is very much present in our body, and that is the carbon-14 that is used for estimating the life of the fossil fuels and all. So that is a radioactive isotope of carbon that is present. Potassium 40 I told you about. And then you have external sources like cosmic radiation, solar radiation. Okay, there are certain stars in the space that give out very strong radiation. Okay, so they are very far, so we are safe. So these account for background radiation. So now we are going ahead with that radiation. So the radiations, we have seen background radiation being one of the source, but there are other source of radiations that what we will see. These source of radiations being radioactive fallout from nuclear plants and other sources. Okay, so nuclear power plant are there everywhere in the world. They give electricity to many part of the world. So because of some accident in the nuclear reactor, large amount of radioactive substances can be exposed to atmosphere. Okay, there will be a long-term effect on the population, that particular area. Chernobyl, for example, if you have heard this, there was one documentary as well on that. There was a you know explosion over there. There was an accident at Chernobyl, and that particular area is still contaminated. People cannot stay there. The nuclear plant which was there, there is a shell on that. Okay, shell as in artificial structure has been made so that it covers the plant. So the whole thing, which was made later on, okay, so that it covers the part where the reactor was. So inside this, there is a big hole where the power reactor was present, and the area is still contaminated. And you can see that in the vicinity, there is no habitation. There is people don't stay there. So the things which were where this existed, there was a city. People were staying. People were working in this place. Okay, so they all have to be settled somewhere else. Even the soil gets contaminated. So the plants which grow and the animals which graze on that, everything gets contaminated. Sources of radiation is disposal of nuclear waste. As I said, if the waste is not disposed of properly, that will cause to radiation. Okay. So now moving to the last part of this is where we will be dealing with some example. The B exercise is cancelled, okay, in this.
The full B
So
part is
this chapter
cancelled.
all theory only, right?
What I'm going to do now are some of the, you can say numericals which are there. This is uranium 238 and 92, which undergoes disintegration to become 20682 lead. So the question that they're asking that how many alpha particles and how many beta particles are emitted. Again, such questions are not expected in the exam, but still, this is the difficult one which we will finish off first. So think about it. This is 238 and 92. So when one alpha particle will be given out, this is going to become 234 and 90. When there will be two alpha particle given out, this will become 230 and 88. Are you following that? When
Yes,
three
sir.
alpha particle will be given out, that will be 226 and 86. Okay, so you can't keep doing this all the while. You can directly think of this. So there is 238 that is becoming 206. So what is the answer to that? 32. So therefore, number of alpha particles will be 32 upon 4. That will be 8. Okay, so the number of alpha particle given out will be 8. So here if I write 8 alpha particles, so this will become 206. But what about 92? So 92 will be 8 times 2, that is 92 minus 16. What will that be? Yeah, 76, right? So this will become 76. So when uranium-238 gives out 8 alpha particle, it becomes 206 and 76. But we need 82. Okay, so you know that when one beta particle is given out, this will become 77. When two are given out, that will become 78. So if you want 76 to become 82, that means 6 should be given out, and this will be lead. So therefore, the number of beta particles will be equal to 82 minus 76, that is 6 beta particles. Okay. Now this indeed is a tricky question, but the kind of questions that you expect in the exam are slightly easy. So let's look at the second question now. So here you have X. This is X1. This is X2. This is X3. And this is X4. You have to complete this question. Now this is pretty easy. If you don't understand, please stop me and ask. This is beta particle. I told you that in a beta particle, Z gets incremented by 1. So what do I have over here? I have A as A, and this is Z plus 1. When there is gamma emission, nothing changes. This will remain as it is. When there is alpha particle, so A is reduced by 4. This atomic number is reduced by 2. So therefore, this will become Z minus 1. Whenever there is beta, this is incremented by 1. So you get A minus 4 and Z. So that will be your final answer. Do you follow that?
Yes, sir.
Okay. Now I'll give you question 3. So question 3, there is a X, there is alpha, this is X1, there is gamma, X2, this is beta, that is X3, this is alpha, 206, 82, and that is X4. This is an interesting question where you have to work backwards now. So this thing, when emitted alpha, it gives this one. So Sanay, what will be this? He's not there, I think. So you have 230, 210, and this is 84. Do you understand that? This is 210, when reduced by 4, become 206. And this is 84, when reduced by 2, it becomes 82. Do you follow that? Okay. Then you have beta. So this is 210, and this is 83, because 83 plus 1 will give you 84. This is gamma. There's no change. So 210 and 83. Okay, Divya, you want to try this one now? And alpha has been given out.
I'm not sure.
106 and 81, I think.
This is 214 and 85.
214,
Because 214 reduced by 4 will give you 210. And 85 reduced by 2 will give you 83.
yes.
So then how come it is the same in the next series?
How come it is same in?
In the next series.
Which one are you talking about?
So the X2.
Yeah. So X2 is, this is X2. And if you go to X3, there is a beta emission. So the atomic number increments by 1. Do you follow that? And whenever there is alpha, 210 minus 4 become 206, and 84 minus 2 becomes 82. Here this is 214 minus 4 become 210, and 85 minus 2 becomes 83. This is 92. This is alpha. This is Q. This is beta. This is R. This is beta. That is S. So what we have is alpha being given out. So 234 and 90. This is beta being given out. So 234 and 91. Another beta, 234 and 92. Okay. One last one we will try. This is X. This is beta. This is X1. This is alpha. This is X2. There is another alpha. And 172, 69. That is X3. Okay. So again, you work backwards. It should be 176 minus 4 will give you 170.
71 and 71 will.
It has to be 180.
And 73. And the last one will be 176 and 71.
72, because 72 incremented
Oh,
by
yes,
1
yes, yes.
will be this. Now, if you don't wish to work it this way, what you can try is, suppose this is, let's say, X and Y. So this is beta. So that will be X and Y plus 1. Now alpha will be X minus 4 and you will have Y minus 1. And over here, you'll get X minus 8 and you will have Y minus 3. So you get X minus 8 as 172. Therefore, X will be 180. Y minus 3 is 69. So Y is 72. So therefore, you get this as 180. Here you will get 72. This is 180. 72 plus 1, 73. 180 minus 4, 176. And 72 minus 1, 71. Okay. So that way also you can try. So these type of questions do get asked in the exam. Generally 1 mark question, so it will be shorter. Not so many fill in the blank will be asked. Okay. So again, going back to the questions that we just did, these were examples of alpha beta decay. Okay, alpha beta decay, this one. Right, so that's the end of this chapter. We have covered all of this. Mostly it is a theory chapter. This is the old syllabus. In the old syllabus, you had nuclear fission and fusion and basic introduction to equations. This is exercise B. Now that exercise B is cancelled in the new syllabus.